Okay, hello everyone. Welcome to today's session. We've seen a lot of interest, so we got a lot of people joining us, especially for the roadmap presentation that Margie organized and Martin joined us. Thank you, Martin, for joining us today from Germany. It's very early in the morning, I suppose.
It's a pleasure. Yeah, it's great to
Thank
meet you. Thank you.
And also we have George Svinas. They have second presentation. So George is the engagement officer at the Standard Australia. So which we are going to discuss about how we can accelerate the standardization of the innovative low carbon cement and concrete. We have a new member in our working group, Sarah Furman from ICOM. Is she here?
Yep. Hi.
Hello. Would you please introduce yourself to our working group?
Okay. I am materials engineer specializing in durability for major projects. So I have a strong interest to see where this side of the concrete and cement will go. So hopefully I can contribute and learn at the same time.
Sure. Thank you so much. We also have a few guests today that they wanted to join to see the presentation. Please feel free to introduce yourself. Probably I can see your name. Warren, are you there? Do you want to? Okay. Wout from Smart Grid, do you want to?
Yes, good morning and good afternoon. My name is Wood from, I'm from UTS as well as from Smart Grid CRC. I'm a professor of concrete engineering at UTS and have a long association, I guess, with work relating to durability and service life performance.
Thank you so much. Okay, so I think that we have going to be a very long meeting today, so I would start with the presentations. And Martin, over to you. Would you please give a little bit of introduction, and then please feel free to share your screen and go through your presentation. Thank you.
Sure. Before I share my screen, I just say a few words to introduce myself, and I do this in this case because I can see your faces. You know, we have been working on this project now since the beginning of this year, I should say, or a little bit later, and it was a fantastic journey. And I'm really happy to see many, you know, which I know even more in this journey. Yeah, and it really has shown, I think, that putting this report together was a starting point to something that you now have to continue. Yeah, this is what came out of this, and you still use this phrase roadmap, and I sometimes use it as myself. The implementation of this roadmap is the next step, of course, but some of this has already started. Yeah, so this report, I mean, you have been working together. Yeah, and as I said before, a couple of people that are in this meeting, in this virtual meeting room, you have been participating, and I would like to give great thanks to all of you have contributed, because this is a report that is not done by us here at VDZ. It's basically your report. We just have been the enabler, I should say. Yeah. So, and having said this, I would like to give great thanks to all of you who have contributed. Yeah, have been participating in these workshops and in these interviews. So, having said this, you know that the executive summary of this report has been published already, and a full report is going to be launched very soon, Margie. Yeah? So I think much of the information is compiled, is available, and it's up to you now.
Sorry about that.
Yeah, it's up to you now to take advantage of this and to further develop this. And it's the experience I have with some of these reports, and we have done it for our own country, we have done it for the GCCA. It's always the same. it's fantastic what kind of power this kind of exercise releases, you know, the togetherness that you create along the value chain to make this transformation happening. And I would really like to underline that this transformation that we are anticipating, you know, is one of the biggest transformations I think we could think of. Yeah? So it's unbelievable. But you will see from this report, and I only pinpoint a few things together today, you will see from this report that all these elements are basically there. So we are not talking about something which is completely impossible. You know, the real thing is, you know, to put all these elements together, and it's for the first time that we have to work along the full value chain. You know, up to now it was a cement producer. We did, you know, we worked on the environmental issues, and the concrete side worked on this, and you know, the construction side. It is the first time, and you will see this, that we have to clearly work.
What's happening weather-wise at the moment?
Along the full value chain. Okay.
Sorry,
so
if you can mute yourself would be great.
Nice. You can sit and chat.
Maybe.
It's not too bad.
Okay, perfect. Just to make sure you can hear me loud and clearly, don't you? Okay, so everything's fine. Then let me share my screen. And you should now see the full presentation, the PowerPoint and full presentation mode. Is that correct? Yes. Okay, so I assume that's correct. Okay, now the title is Decarbonisation Pathways for the Australian Cement and Concrete Sector. We sometimes talk about the roadmap because it's a little bit more you know, easy to say, and it's kind of, you know, but I refer to the decarbonization pathway here. And you know, very short, you know the framework. You know, it started all in Paris in France. You know, and at that time, you know, we first talked about the 2 degrees, and now it's 1.5 degrees. And the conclusion is ultimately, you know, that our world has to decarbonize. You know, and I still remember, you know, when we first used the word decarbonize, you know, nobody knew what that really meant. Yeah, and it was kind of a strange word, decarbonizing cement and concrete. You know, what we got to know is it, and what really is great that, you know, we got to know the elements of how we are going to do this. And decarbonize basically means, you know, to reach. You can call net zero CO2 in 2050. Some talk about carbon neutrality. So there are some words, you know, which are similar, but for the report we have chosen net zero because in the context of what you are doing in Australia, you know, this felt for most participants the right term here. And you know, you also know that something is happening now in Scotland, you know, in Glasgow, at the COP26, and you know, I think that the target that had been set in Paris is now going to materialize in Glasgow, and it's also fantastic to see, you know, how the world is getting together there, and what you know, and it's going to be interesting for us to see what will come out of this, you know, because I expect quite a bit of guidance here, also for our industry. And having said this, you know, of course, we can talk about targets in 2050, and you may have heard that in our country, in our region, they just, you know, put it already to 2025. And, you know, at the end, I think the most important thing for us, and that also is true for the whole cement and concrete sector in your country, is that we start. We should not lose years at the very first beginning, you know, whether 2045 or 2050 is the final target. That's another story, and of course we got to really do our best to achieve net zero emissions at a given time. But the most important thing is that we have to start. Yeah, if all the years that we lose at the beginning, you know, are very difficult to make up at the end. Now, this is everything that you know. I should not tell you, but it's just to explain a little bit, you know, that we cover the full scope of the value chain for the very first time. Yeah, so. Of course, the CO2 footprint of construction in the broader sense is basically, you know, originating from the CO2 emissions from cement making. But you will see, you know, that you know, it cannot only be done at the very first beginning. We need the full value chain of reducing CO2 emissions to finally achieve net zero at the very end. And I'm very happy, you know, that you have invited me here as MECLA to give this presentation today, because we will see that, you know, if we don't work together here and we don't have a pull effect, you know, from, I would say, from the customers, from the downstream area, you know, that's not going to work. Yeah, and I know that you are cooperating with the climate active action partnership in your country with the Green Building Council of Australia. So these are all very, very, very important organizations or platforms, I should say, which are essential, to make this whole exercise happen. And I should already say today that when we started this journey and when we had all these workshops with you, some of you are in this meeting today, but also with others along the value chain, that you clearly could feel, and I've felt it here in my own country, that we all, once we talk about this, and once we strive sometimes, when we struggle sometimes, for what might be the right pathways, what might be the right elements, what might be, the timeline, and who does what, with all this is needed in order to make it happen. And I think we need this kind of friction sometimes also, whenever we talk about wording, when we talk about elements of this transformation. And what clearly came out is a strong commitment of those people I have had the pleasure to work with in this project, that they are fully committed. Yeah, and I have to say that this set of pathways, is really, the base to enable the cement and concrete sector value chain to fully decarbonize CO2-wise by 2050. All the elements are here. It's not an easy exercise, but it's doable, and that is something that should make us what is the English word? To look forward to this, because we can really do something here together. And one thing is clear: construction is always needed. We always need construction. There's no way to get along without cement and concrete and buildings and infrastructure. This is what our life is built on. The only thing is, we can look at the elements along this value chain to make this happen in a way that at the end, everything, the whole value chain is fully set to net zero CO2 emissions. Now the starting point is, and then I've the element here from this flow chart is, of course, the clinker and cement production. Yeah, this is the starting point, because you can see here at that bar, the main challenge that we have, and that's a big difference, as you all know. I should not maybe tell you, but you all know that we have in our clinker production the issue of what we call process emissions. Yeah, so we have CO2 from our limestone, and for 1 kilogram of clinker, you always have a certain amount of what we call process emissions, and these process emissions per clinker cannot be avoided with just changing the process, except capturing the CO2 at the very end. So the clinker is a given, yeah. And of course, we also need energy for making this mineralogical transformation happening in our cement kilns. And because it's a high temperature process, we also have it's quite a bit of energy that we require. And as a rule of thumb, as many of you know, is we have 2/3 of process emissions CO2 from the limestone, the decarbonization of the limestone, and the 1/3 comes from the fuel. And in other processes, we are able to decarbonize the fuels, the thermal part, and that means to switch to electricity, for example, yeah, to switch to green fuels, for example. So this is also partly possible here, but it's not possible to substitute or to decarbonize the CO2 that comes from the limestone, because limestone is the base material for clinker, yeah. And the amount of limestone that we need, from the limestone we need the calcium oxide, you cannot substitute, yeah. Not maybe in niche products on a very local level, but in general, this limestone, and we can be very glad that this limestone is available abundantly worldwide. This is the essence. Now, when we talk to the fuels, and you will see a little bit later on, of course, that this report, also contains a pathway focusing on making the CO2 emissions from the fuel utilization less. And the keyword here, of course, is alternative fuels with biomass. And the second keyword here is the use of hydrogen, and I will come back to this in a minute. Now, these are what we call, and the experts among you, that we talk about scope 1, 2, and 3 emissions. These are scope 1 emissions when you look at this from the cement industry side of view. We have included in this report scope 2 emissions from the indirect emissions from the electricity production. Yeah. And we have also included some part of what is called the scope 3 emissions, namely transport. But we have not covered all the transport. What we did here, and that is just just approaching this issue very tentatively. We have only included here the transport from the materials down to the customers, cement to the concrete plant, and from the concrete plant down to the construction site. So that is what we have included here. Now, having said this, the starting point for me, and I'm working for the cement industry for more than 30 years now. I mean, what are if you listen to the cement producers and the concrete producers and to the market, what are the key themes which they feel are important to make this transformation happening? What are the positions and what are the fundamental approaches before you go to the fine tuning later on for this transformation? And one thing is the lowering of the clinker factor. I mean, maybe I should not tell you, but if you have clinker in cement and clinker finally then in concrete, if clinker is the ingredient along the value chain, that is the origin of quite a bit of CO2 emissions, basically due to the process emissions, then of course the most efficient use of clinker is the first thing to think about. Yeah. So, and from a cement point of view, we talk about the clinker factor, and from a concrete point of view too. And the clinker can be replaced in cement or in concrete, but by SCMs. That can be fly ash, or it can be slag, or in the future it's going to be calcined clay. So that is something that can be really further developed, and there's quite a bit room for lowering the clinker factor. I have to say that in Australia, in particular in the concrete part, the clinker factor, we call it the clinker binder factor because we refer it to the binder content in content is already at a very good, and that means at a rather low level. So there is still room for improvement, but I have to say that we're using quite a bit of SCMs already, in particular in concrete, but there's still quite a bit of potential when you look at cements with lower clinker factors that can substitute or support the whole development along the value chain. But this requires a regulatory framework which reflects this, and it is like in many countries, technology and the willingness to transform has to go hand in hand with a regulatory framework. Yeah, and sometimes it is not that still needs to be developed, and I think what MECLA is aiming at, is also kind of a framework, in which carbon, for example, gets a higher meaning, along the value chain as compared as it has today. So carbon in our value chain, or CO2 in our value chain, embedded, or I think you say embodied carbon. Yeah. Carbon in building and construction needs to get more attention, because energy is very much in the focus when you have a building, for example, but CO2 is not yet, and I think that's part of this regulatory framework. And it has also to do with the standardization. Yeah, standardization as the standard as such, but also standardize some of the regulations to make this transition process happening. And it has to do with the cement standard. It has to do with the concrete standard. So I mean, you being expert, in your specific field, you know exactly, where the weak points are in standards. The beauty of standards is, they are made for basically. And then what the word standard means for everything to reflect the full potential of basically the average. But I think with our standards we have to go beyond today. We have to make sure that these low clinker containing cements, that these low clinker containing concretes at the end, that they are reflected in the standard, so that they are getting more usable for the applicants. And it's also important that these standards are supported by governmental regulations when it comes to the application of concretes. And I know that in many countries, and that's also the case in Australia, I mean, you have standards on one hand side, and in principle you are able to produce this concrete, but it's also that some authorities, they have their own approaches. We know from the road authorities, for example, from the infrastructure authorities, that they have dedicated rules, that are beyond or parallel to the standards. And I think we have to make sure in this whole exercise, that we closely work together here, that we that these, regulations are not contradicting each other. And it's also the case that, you know, these kind of authorities, they have you know, they are kind of examples, you know, if, you know, they are the front runner, they set the pace, you know, if you know, in this exercise, it's able to win them, you know, and to make, you know, things together, you know, then of course they are like in public procurement, yeah. So I mean, it's so important to have them, you know, fully integrated in the process and being committed, because they are the examples, you know, they set the pace at the end. While the standards, you know, is something that is standards are patient, you know. I mean, standards, you know, they have to be implemented, but you know, the real power comes, of course, from those who decide, you know, what kind of material is used at the end, what kind of concrete, and how we build in concrete. And that brings me to the next point: transition from product push to market pull. And I think that that's an experience that we have made in all these, you know, discussions with you, but also, you know, in our country, for example. You feel at a certain time, you know, that industry, you know, is really, you know, willing to be part of the solution, you know, and that they are developing their products, you know, they are working on their kilns. They have issues, and I'll come back to this in a minute, like carbon capture they address. But that's only going to happen if the market also accepts these cements at the end, or these concretes at the end. And they are not different, you know. They are still durable, you know. They are still affordable, you know. They, of course, they have different prices, you know, depending on what effort has been taken to reduce the CO2. But at the end, you know, it's the customers, you know, that the customers that really need to ask for these products. It's otherwise it's not going to work. And the question is, you know, and I think that's a question that you will put as MECLA and in cooperation with the Green Building Council, for example. The question is, you know, how can, you know, what are measures to make this market pull happen? Yeah, because it's not going by itself. Because in many cases, and I think the same is the case in your country. You know, the price. You know, price is at the end is most important. And second, you know, it's low complexity. You know, so it must be easy. You know, one size fits all is a typical approach in our country. You know, one size fits all. You know, we don't need different concretes with different concrete compositions. Even, you know, if we have exposure situations where we could easily, you know, build with concrete that had even lower clinker content. As it has today. So this is kind of what has to happen. And of course, then we need a certain context, you know, for these different pathways to really happen. And that has also to do, you know, and I come back to this in a minute, you know, infrastructure for CO2 and infrastructure for hydrogen, you know, more access to biofuels or to alternative fuels, for example. And this is the starting point of the value chain. But along the value chain, you need this kind of context, you know, and in which this can really take place. You may have seen in the executive summary that we have broken down this whole exercise into what we called pathways. You see the reduction here, and, you know, without going too much into details, of course, we have also anticipated, you know, what is the market volume in 2050. Yeah, Australia is a growing market. I mean, you have a growth in population, for example, and the expectation is that you need if you wouldn't do anything else, you know, you would need 40% roughly more construction in 2050. Yeah, and of course, you know, this is under a business as usual condition. But the thing is, of course, you know, that, you know, it's not only starting from the clinker side, but you're looking at the construction side. There is something, and I would like to draw your attention to the second pathway, the second from the left, innovation through design and construction. We will build more with less. Yeah, and those of you being the expert, you know, in construction, yeah, being the ones, you know, at the market, you know, and then you know how construction goes on in your country, and you certainly know how construction goes on in other countries. There's still quite a bit room for improving, and improving means here innovation through design and construction. That has to do with material efficiency, and less material in general means less cement, less clinker, and ultimately then less CO2. And the potential that we have here is quite significant. It's a little bit more than 20%, and that is based on the many experts interview that we had with all of you. Before I come to the very left one, let me just continue further to innovate concrete. And we have to continue. I mean, you are not starting from zero here. I mean, as I said before, there's quite a bit of SCMs that you use in your country, but there's still potential to further use SCMs. The question is, what are the SCMs of the future? Yeah, if the power sector is continued to decarbonize, then at least fly ash production will be less. But we have, of course, like in many countries, we have quite a bit of fly ash stockpiled. The difficulty is that some of this fly ash, in particular in your country, is ponded. You know, you have brackish water, it's chlorine content, for example. And the question is, how can you process them? And you will see later that one of the innovation areas that we have suggested is to have a dedicated look at this fly ash, which is sitting there. The amount is tremendous. The question is, to what degree can you make use of it? Today, it's many of these things are not economically viable, yeah, because it's too expensive. But at a given time, you know, when this journey, you know, has started, you know, and when the whole value chain has started to implement these measures, and when the framework is there, we will certainly have something like a value for CO2 that can be a carbon price or something else. Yeah, but then, of course, you know, some of these measures, they really will make sense. You know? And to fully understand this in your regional context, we have suggested a dedicated innovation area on this. Now, when you come, and that goes along with the next one here, the further use of SCMs in concrete. The same applies then for CO2 efficient cement. If you look at the clinker content in cement in your country, there's still room for a higher degree of SCMs to substitute clinker in cement. And again, the question is here: what are the SCMs of the future? We talked about the fly ash. When it comes to slag, the question is how the steel sector is going to decarbonize their value chain. And depending on the route they take, you know, the slag, the amount of slag and the quality of slag, you know, will change in the time to come. We have not really touched upon this here because, you know, that's still some open questions there, which of course you have to look at in the time to come. But there are other SCMs, and one of them is calcined clays. Calcined, I mean, clays, you know, the clays that we would use for replacing clinkers, you know, these are not the very high quality clays that you use, for example, for the porcelain industry. No, these are the kind of clays, you know, that not only contain the kaolite, you know, these are typical clays that you find in open pits or in quarries. And there's quite a bit of resources when it comes to clay available in your country. And you have to calcine them. That means you have to heat them up to a certain temperature in order to make the minerals in these clays to be available. In particular, it's the silicate that you need for the reaction to provide strength to cement in concrete finally. And that can be done. The beauty of these calcined clays is that they don't contain the process emissions like we have for clinker. So there's no limestone in it, yeah, basically very, very little calcium carbonate. And you only have the CO2 emissions from the fuels, and it's a much lower CO2 footprint. So the calcined clays have a high potential. And next to this, I would also underline the potential of limestone. Limestone as an SCM in concrete, but also in cement. And we are running experiments here with 50% limestone as a clinker replacement in our country. Yeah? And I think, you know, these are, and we are at the very first beginning, but it works. Yeah? It really works under the conditions, of course, that you have to look at very carefully. What is the exposure class, for example, for the concrete we are using in it? And you might, and I think that is also an issue that we have addressed, you know, have a dedicated look at the concrete standard. Yeah. Some elements are prescriptive, some are performance oriented, yeah. And even if they are performance oriented, the downstream users, infrastructure, or authorities, road authorities, you know, still, you know, go back to what is called prescriptive approach. And the limiting factor in our country, and you know, you will discuss this internally, is the water cement ratio, for example, in concrete. And you test with much too high water cement ratio, and at the end, you know, these these concretes don't work. So I mean, you can do quite a bit, you know, in concrete technology, and this goes all hand in hand. You know, these SCMs, extended use of limestone as an SCM in cement and concrete, for example, goes along, of course, with the innovation in concrete production, adapting the water-cement ratio, yeah, maybe shifting from the 28-day strengths to the 56-day strengths, yeah, in order to make sure that we provide sufficient time for the hardening process. The potential is there, but maybe these concretes don't harden as quickly as they used to, yeah, but it's not a fundamental barrier, you know, to implement these materials. There's quite a bit of you know, and it's for me, you know, it's very promising, you know, because they're all elements, you know, where you can all work together and where there's a huge potential. Now, alternative fuels, I just mentioned this. You know, when we look at the 1/3 of the CO2 emissions from our kilns, then of course, you know, the question is how can we replace this? And alternative fuels that tend to have a high degree of biomass, yeah. In particular, when you have, you know, look at your waste streams in Australia, they can be more, I think, taken advantage of than you do today. There, of course, again, you know, no one size fits all. It has to do with the local availability of these materials. Transport costs, they play a role, of course, you know, but this is something that you will have to work out on a country level. But in principle, there's no technical barrier against the higher use of alternative fuels, and there's a huge availability of these alternative fuels. We need guidance from the legal framework, from the legislation, of course, nationwide, but also very local, of course. And the other thing is the account for concrete to uptake CO2. We all know, and you know, being concrete experts, some of you know that carbonation is a very typical phenomena that we have in concrete. Of course, you know, we have to take this into account when we have the cover of the concrete when it comes to the reinforcement. But nevertheless, carbon is taken up, and the term is recarbonation. Now, this is a natural fact, and it has not taken into account so far in any of the carbon balances that we have on a local level, on a national level, or even on a global level. But for the first time, the IPCC, the International Panel of Climate Change under the United Nations, has addressed this and acknowledged that a certain amount of CO2 can be taken up. Now you could say, you know, this is just numbers. You know, it's not going to change the world. It's just the numbers are going to change. I would say that's true, but it's important that we get, you know, this acknowledged. You know, that means basically that we can subtract some of the CO2 that we directly emit along the value chain. But the other point is, and those of you being working at this part of the value chain, and looking here at smart grid, for example, yeah. So you know exactly that recarbonation, when you break concrete in order to recycle and to bring it back into the value chain, you know, you increase the surface of it and you have an increased uptake of CO2. And this is something that, of course, can be further developed. And there's quite a bit of research going on in this field. And I think this is a potential that we can use, you know, recycling concrete to produce new aggregates and taking advantage of an accelerated recarbonation process is something that is really worth to have a deeper look at. That's I wouldn't call it the low-hanging fruit, but it's something, you know, technically, you know, it's understood. And the question is how we can transfer it into processes which make this recarbonation happening in a more happening, you know, to a higher degree. Yeah. But part of the truth is also, you know, that at the end, you know, all these elements have its limitations, and there's 1/3 of the emissions that cannot be avoided with these pathways I have pointed out so far. And I have to say that if you look at these pathways, you know, the numbers here, which we estimated in our model, you know, based on the interviews that we had with you and on the workshop, this is going to a certain limit, you know. It is driving basically existing technology towards innovation and towards the limits as we see them today. Yeah. And at the end, and it has to do with clinker. We cannot fully replace clinker along the value chain because the clinker is today and it's going to be the power horse in cement and concrete. There's no hardening of concrete without clinker. And this is then the ultimate question: what do we do with the remaining CO2 emissions from the cement kilns? And the answer is carbon capture. And you may know that carbon capture technology is a technology that has developed over the year, but it's available. There's quite a bit of research going on worldwide in carbon capture, and I know that carbon capture also, in Australia is addressed by the government. And the low emission policies, for example, carbon capture is clearly addressed here. And I have to say that Australia is a blessed region and a fortunate region when it comes to carbon capture. I mean, you have experience in handling gases, and in particular also CO2. And if you go into the details, you will see that handling CO2 and carbon capture and re-injecting and storing carbon capture, for example, CO2 is actually in the oil and gas sector is known technology. There's nothing there, which is brand new. But the point is how can we take advantage of this? And what we need is, first of all, the technical solutions for the kilns. That means we have to further explore, what is the best capture technology for each and single kiln. That has to be answered in the context: how much space do I have on my plant site, for example? Do I have access to oxygen, or do I have more access to renewable energy? And these are all detailed questions. But at the end, there are solutions for carbon capture. The biggest question is what to do with the CO2. Yeah, and having said that 2/3 of our CO2 emissions comes from the limestone. As a rule of thumb, for a ton of cement, you end up with between 500 and 600 kilogram of CO2, and this is quite a bit. It's a huge amount, and we need an infrastructure for the CO2, and of course we need measures to handle the CO2. And one solution is storage. And I have to say that the experience that we have in your country and the availability, of the knowledge that is there, storage, of course, is a good choice. But also the question is at the end to close the loop. Recycle the CO2 is an option. You may know that CO2 can be converted to synthetic fuels. With some questions, of accounting, but it can also be converted into base chemicals, for example, to substitute fossil based raw materials for the chemical industry. But the CO2 to be converted requires quite a bit of energy. And the reason is clear. I mean, CO2, for example, when it comes from combustion, it has released all its energy. Yeah, it has released all its energy because we have taken it as a fuel, and the end product is CO2. That means, and the opposite, to return this back to something else, requires a lot of energy. And it's clear that this energy has to be zero emission electricity. Yeah, so for sure. And again, and that brings me to the first pathway here: zero emission electricity and transport. I think as Australia, you have an excellent starting point when it comes to zero emission electricity. We have anticipated and assumed in this report that the electricity sector is going to be fully decarbonized, or I should better say, I know that Australia have local electricity markets. That the cement production can fully source zero emission electricity in the time to come. And the same is true for transport. If those sectors, the energy producers, the transport sectors, are taking the transformation to net zero as serious as you do it, as we do it, then for sure these sectors will also be fully decarbonized by 2050. And this has been anticipated in this year. This is the same pathways with much more text, and I'm not going to read the text for you because I've already started to explain this, but I just wanted to show this is going to be part of the full report. And all of these pathways are explained in a much broader way than I'm able to do it right now. And it leaves, at the end, it gives you the base to have the further discussions based on the findings of these reports. Now, what are the requirements? What are the facilitators? What can make this happen? Yeah, and what are the overall assumptions? The first thing is, of course, and I mentioned this, the Australian electricity grid will be decarbonized by 2050, and the same is true for transport. Now, and when it comes to the fuels, I think there's also a legal framework that needs to be adapted to have access to sufficient alternative fuels, in particular to fuels containing biomass. There's no principal obstacle, as I said. There's sufficient ways available, but it has to do with logistics, for example. It has to do with access, but it has to also to do with strong competition from landfills. In your country, and it's in many countries, also in our country, it used to be that the landfilling is, if you allow landfilling to the degree as today, nobody can compete against landfilling. The cheapest, yeah. But it's also from a CO2 or greenhouse gas emissions point of view, it's the worst, yeah. So we rather take advantage of the biomass in a in a smarter way. Carbon capture production must be technologically deployable. In the full report, there's all these technologies are given there. The technology readiness level are underlined, and just to make it very short, as I said, these technologies are available. They take a lot of investment, yeah, but it's an investment which is looking at the time frame we are talking about, it's doable, but it requires a legal framework to make sure that this investment, and I'm talking about the capex, and I should not forget the opex, the operational cost, are somehow reflected, then in the utilization of the cement. That means, these cements, of course, must find their way into the market, and I think this is where your group, where MECLA, where the Green Building Council of Australia, and the whole Climate Action Partnership, is kind of, important to make this happen. Now, this requires also the infrastructure for CO2. I mentioned this, and of course, the product and design standards. They have to include this, and I think as further you go down the value chain, as more important this is. We talk about market acceptance. We need to talk about what are the facilitators here. And I have to say, the experience in our country was the biggest obstacle is we have done it one size fits all, and the differentiation, of course, is the biggest in today's way to construct is the biggest obstacle. Yeah, the technological solutions are more or less already there, yeah, to some degree, but it's a question how do we get all of us being included in this, being fascinated by this aspect that it can be done. And finally, recarbonation during concrete life cycle stage. I think it's more than fair that CO2 plays also a role when it comes to recarbonation in the balance of the CO2 emissions. And on the other hand, it's a question, how can we, support actively recarbonation, in particular when you use concrete as aggregates when recycling buildings or infrastructures at the end of their life cycle. Now, the last slide here is on the innovation areas. The question was at the very first beginning: is there anything that we can suggest, to make this happen? And I think I still like this very, very much. It was a very smart approach, because all what I'm saying here today is nothing, that comes from a single source. It comes from many sources, and we have to join forces here. And sometimes we have to join forces, not even know exactly, what the outcome is. We know in principle it works, but we have to fine tune it. We have to we have to push innovation in some degrees, but we also have to find the right solutions. And this can be best done in what we call innovation areas. And a couple of them are listed here. Maybe I won't read all of them, but I can maybe pick a few of them. And they are suggested in the full report, with details. What is the starting point? What are the work packages that we suggest? And what might be the deliverables at the end? And I have to say, I'm really, it's really great to see how Australia, how your country is structured when it comes to cooperative research. The CRCs here, it's fantastic. You have good universities, you have industry partnership here, you have the industry itself contributing, you have trade associations being part of this. I think I have not seen this so far yet, in other decarbonization pathways that we were able to support. And I think you can really build on this. And this kind of cooperative research or innovation areas that you create, that you have to build up, of course that they require some funding, yeah, for sure. And I have understood from the Australian government, that there's a willingness to support this. But I think the funding is of course one thing. The other thing is that you find yourself together, that you work together on these issues, because working together on these issues not only comes to solution, but it comes to a common understanding, because the solution is maybe not so easily to be seen. It needs to work together. And I think from MECLA's point of view, I think the issues like here, the specification for concrete durability by performance, for one, is certainly one thing. The database of the property of low carbon cement and concrete might be another one. Just collecting, the properties of low carbon cements and concrete to make sure, that they are fully understood, and that there can be cases, that you can show to others, to the value chain, what is possible. We need more case studies that can be shown in order to make this transition happening. And we have in our country, we have database here on low carbon cements. At that time, we thought they were low carbon. Today, I would say, they're not low carbon enough. But we are giving these examples, of course, under our conditions here. And the suggestion came from the workshops, that came from you. Why don't we just build up a database on the properties of low carbon cement and concrete in our country? Beneficiation of fly ash, I talked about this. That's not an easy exercise. And David, I know that you are in that meeting here. We have talked about this here quite a bit. It's not easy, but the material is there. There's silica, there's aluminate in this ashes. It's glassy, and I mean at the end, it has hardening properties. So it has pusillanimate properties, and the question is to what degree, for what cost. Can these fly ash potentially be recovered and to be made available for cement and concrete? Additive manufacturing and digitization is a key issue here that still for many of us not quite sure in which direction that can go. But here again, I would say, this innovation area is a great one, to learn together on this and to implement this in the value chain. Resource efficient design principles, as I mentioned, savings in design and construction is significant, but this requires again, working along the value chain. And one of the innovation area that we suggest, to have a dedicated approach here, with many partners, stakeholders along the value chain to have a look at this. And this can all include, in each of these just mentioned innovation areas, the CO2, embodied, in the material is important. I think I think MECLA can play an important role. It is not 100% clear yet what is the best way to account for the embodied CO2. You can do it per cubic meter of concrete, per cubic meter in megapascal, and so on. There are many things. Some are easy, and maybe not as good. The others are more complicated but better. And you will find your way here along the value chain. And I'm really happy that I had this opportunity to talk to you and to give these recommendations here. As I said, this report can be accessed here at the CAF website here. And I would also like to thank the many of you, and some of you are here in that meeting today, but the others, who have contributed to the success of these decarbonization pathways. The ones who have contributed here financially, and Warren, I know that you are in this meeting here today. Thanks for you for all your partnership that we felt, in this process here. CCAA, again, I think you are here as well, and of course, Margie, you have the ones, we were the one, who has contacted us and to introduce us into the Australian cement and concrete sector. We have been well received, we have been in a very open and very appreciating way. And having said this, I would also like to give great thanks to that you have invited me today here to give this presentation. That was an overview. If there might be any dedicated questions, so we can talk about them now. But it really goes down, for example, to dedicated question on concrete experiences, so on. My colleague Christoph Müller, who was not able to make it today, is also available, and some of you know them from the small workshop that he had with some of you in one of the last months. Having said this, I think I unshare. I think that's the right word. My screen, that I can see all your faces.
Thank you so much, Martin, for your great talk and your presentation. I think that's very little bit over time, but it's really worth it to.
Oh, sorry. No.
That's okay. So I think that we have only maybe 5 to 10 minutes, so for a few questions. So if you have any question, please raise your hand. Wood, please go ahead.
Yes, my question is regarding how recarbonization or carbonation. I feel that a lot of low carbon concrete has the potential to carbonate much faster than conventional concrete. And how can we make full use of it? I have two area that I want your experience with it, and that is the use in concrete road pavement, where we tend to have fairly large concrete cover, which means it can accommodate concrete with higher carbonation rate. And if that type of concrete is used in Germany, for instance, was there any issue with abrasion resistance of that type of concrete? So that's my first one. My second one is regarding, again, the use of concrete, which may carbonate faster than normal. What is the potential to use galvanized reinforcement with that type of concrete? Would that compensate for the high carbonation rate of that concrete? Whether that is your experience in Germany as well. Thank you.
Yeah, good. Thank you so much for this. It's a valid question. Very, very good questions. Now, the carbonation rate of concrete today must not deteriorate when we go to low carbon cement and low carbon concrete, and in general, because we have our exposure classes, and of course, they correctly said, they are there, and I think it would not be wise to change this. Yeah. So what we do is, of course, we look at the concrete mix design. Yeah, the concrete mix design will be different in the time to come when we go to low carbon cements, for example. So we are talking about the water cement ratio here that has to be adapted. Our concrete standards today, and I think that's the reason for your question. Our concrete standards today are not fully adapted to this development. We have to work on standards. So I think that's but it's doable. Yeah. When it comes to other reinforcement, that's a very good question, and I have to say there's a lot of research going on this carbon reinforcement. Yeah. So and this is very promising. Yeah, because you don't need the cover. Yeah, the concrete cover as to the degree that we have. But it's at the end, it's also be an economic question. Yeah, the economic question. Yeah, the carbon fibers are more expensive. They are difficult to recycle. And I think that could be something that you could address, in your environment, because there's probably not one solution that you can easily transfer. But this is the research that's going on here, with textile reinforcement and in particular carbon fiber reinforcement.
We don't have more questions. Martin, I have one question, and that is probably sets our theme to next presentation by George from Standard Australia. So how do you see and how do you compare the process of the standards and obstacles of that for the thing that is happening in Australia compared to the thing that's happening in Europe? And which methods do you think that would help in order to accelerate, new binders, new methods, new decarbonization pathway that you mentioned. So how do you see that this barrier can be lifted, or standards can help in order to accelerate those kind of things from your perspective when you compare like in Australia to Europe or US or other countries?
Oh, that's a very, very good question, Ali. Yeah, so that's a very good one. Yeah, I mean standards are, you know, when I think about standards, how I grew up with standards, you know, for me, the standards was a slow developing process, you know, and to be always on the safe side, you know, and to make tests and tests and tests. So I think that even, you know, from a standardization point of view, I think we have to more optimistic, you know, that standards can even standards for in my experience, we're just following the development. You know, we had technical approvals first, what we call it, you know, and the case by case permits, and then came standardization. And I think this role can be changed if you guide standardizations technically in a very profound and sound way. You know, you can certainly make sure that standards play a much better role, much higher role in the time to come. Yeah, for sure. Yeah. And I think there's no one size fits all solution that you can transfer from one country to the other. You know, it's kind of the way standards are made in your country. It's the question how they are applied, whether there are, you know, other routes, you know, to build. You know, as I said, you know, we have to call technical approval. Yeah, if you go there, just one short cement with these new cements coming up, you know, with 50% clinker only. Yeah. With limestone and with limestone and with slag. You know, the standard is not ready yet. The concrete standard is not ready yet, but you can ask for technical approval, yeah, at the building authorities, and then you make it happen. Yeah, and I'm not sure to what degree that is possible in Australia, but I would really, you know, encourage, you know, that in standardization we need a sense of easiness. I would say, you know, a more not being, you know, always, you know, saying standards must be, you know, compiling the knowledge that we have gained for many years. No, the standards should be also more innovative. They should be future oriented, and then I think much more can happen as can happen today. Super.
Thank you so much, Martin. I think again, thank you for joining us today and going through the roadmap. Margie just shared the link to accessing the full reports, and I think that's on behalf of our working group members. I'll thank you again for joining us today and go through the roadmap. Thank you.